Lesson 4 in the unit starts volume. Today we're going to look at volume of prisms and pyramids, and the key idea is to be able to calculate the volume of these two objects. So first of all, volume is the measure of space a three-dimensional shape occupies. Think of it as the stuff inside. So when we talked about an orange, I said think of the surface area of an orange as the peel. If we thought about an orange, then the volume of the orange would be the stuff we eat. If you think about a paint can, then the metal would be could be thought of the surface area, the actual physical paint can, and the stuff inside would be the paint. So the amount of paint would be a way of thinking about the volume. The units of volume are three-dimensional. So our units are going to be cubic centimeters, or cubic millimeters, or cubic inches. And again, you might literally think of a cube, and a cube is three-dimensional. So if I were going to quickly draw a cube, that's a prism. It's a square prism, a cube, but again, we have three different directions, three dimensions. Now, I mentioned this earlier, the word base. Base becomes really important when we talk about our volume because every shape has a formula. And many of the shapes, the formula depends on identifying the base. So in a prism, the definition of a base then is one of the parallel sides or the bottom of a cone or pyramid. So if you look at this prism, consider it to be a shoebox. Well, the bottom could be considered the base. But the key idea is for something to be a base, it would have to have a parallel side. So the parallel side to the base would be the top. But the thing about a prism is, rectangular prism anyway, it has three different bases if you want to think about it. So the left-hand side is parallel to the right-hand side, and the back is parallel to the front. So again, it really doesn't matter with a rectangular prism what the base is, but remember before in the previous example and homework we looked at a triangular prism, and a triangular prism, the base is literally the triangular ends. Think of a Toblerone bar. So the formula for every prism, it doesn't matter what it is the area of the base, and this is why it's important to be able to identify the base, times the height. And in this case, on the rectangular prism on the left, the base would be L times W, and the height would be H. But generally, you see it written like this. So again, the area of the base depends. And it depends on, what is it? But the area of the base is simply the area of a rectangular or the area of a triangle usually. So pretty straightforward. And again, remember, units are cubed. Well, the area of a pyramid is almost the same. The volume for the area of a pyramid is 1/3 the area of the base times the height. Now, again, this is that important distinction we made before. This is our height that we want, not the slant height. Remember, look in your notes from surface area, the green line would be the slant height, and that's for surface area. When we talk about the height of a pyramid, we're talking about how tall it is. So in this example right here, again, it's a rectangular pyramid because it has a rectangular base, but the volume is equal to the area of the base times the height. Now, if you want to see, again, this is a really nice relationship. if you want to see why it's exactly 1/3 of the area of a prism, because remember, this thing right here, that's the area of the prism. That's that formula we have above. If you want to see why it's exactly 1/3, there's a really nice visual at this YouTube location. So go have a look at it. It's kind of interesting and it's easy to follow. So let's do some quick examples. And again, one of the keys in doing these questions is identifying the base and then making sure we put the right numbers in the right place. So in this example right here, again, my only two parallel sides are this end and this end. So those are the base. So the base in this prism is a triangular base. And the area of the base is equal to 1/2 base times height because it's a triangle. And then the base is 4 in our example, and the height is 6. And 1/2 of 24 is 12. I'm not going to put the units in right now. I'll leave the units till the very end. So the area of the base is 12, and the height is also 12. And now the volume of this is equal to the area of the base times the height. And again, the area of our base we've already calculated, and our height we know, and that leaves us to 12 times 12. And again, remember, our units are always cubed. So 144 cubic centimeters. So the way I like to do it is I like to figure out what each part of the formula is and then plug it in at the very end. And I think it works better that way. So let's have a look at a pyramid. And again, it's important that we know that we want the height, the tallness of the pyramid, not the slant height of one of the faces. So in this one right here, again, the area of the base is in the formula, so we have to know what is the base, and the base is a square actually, but it doesn't matter. You could say it's a rectangle. It really doesn't matter. So the base is square, and then the area of our base is equal to, well, L times W, which in this case is equal to 20 times 20, which is 400. And again, that's 400 square centimeters. We're not going to worry about our units right now. The height is 25 centimeters. And given that we have these parts, well, our formula is 1/3 area of base times height, and 1/3 400 times 25. And when you plug that into your calculator, you get 3,333.3 cubic centimeters. So again, as long as we know the formula and as long as we put the numbers in the correct place, we will get the correct answer.